as fast as we've been moving. And that's okay. All right, so stop me as soon as something makes sense. The unit circle. I've given out, it's a bit egg-shaped, but not bad. I've given out these, unfortunately, the ones that I photocopied, I meant to do it in color, and it came out in black and white. And I hate wasting paper so much, it's what I gave you. If anybody wants a color one, just let me know. I'll make it for you. But it is, I attached these on Classroom. Okay, so everybody will have. Now there's some, the notes for today, what I prepared, and I'll post those as well. The textbook goes a little bit of a different way around the unit circle than I want to. So I'm going to give you that to read later, but I'm going to teach it to you the way I think makes the most sense. Okay? Because, so basically what goes on, you know what, I'm going to flatten this a bit so I have some room at the top. It's rounder. It's like an oblate spheroid. So I'm going to, do it the way I think makes the most sense. So on a unit circle, it's called a unit circle because the radius is 1. It's 1 unit. And you treat it like this is the coordinate plane. So right here is 0 and 0. This is 1 and 0. This is 0 and 1. This is -1 and 0. And down here is 0 and -1. Right? Those are the x and y coordinates. Now there are lots of different angles that we will need to kind of memorize and need to fully, which side has more space? This side? Okay. That we'll need to be able to get. When you get on the provincial exam that you guys are not writing, one of the things you are given is a sheet that's just this. It's just the unit circle empty. Because there are questions where you're going to have to be able to figure things out. And you'll have to know what the points are for every single one, what they are in radians, what they are in degrees. It looks overwhelming, but it's not. There's ways to do it. The textbook kind of wants you to, in a way, memorize. I want to teach you a way so that you understand it, because then it'll last longer in your brains. So the simplest, most basic, maybe I'll do them with different colors. Try and keep track of what's in what. So in degrees, we'll go red. So this is 0, but it's also 360 degrees right here. 0 all the way around 360 degrees. Right here is 90 degrees. By the way, the reason I'm giving you the blank ones is for you guys to practice. Because I think even on the other side of this one, is it blank one as well? Yeah. So you have 3 blanks. If you want more blanks, say so, but it's for you to try and do this without looking at anything. 90 degrees here, 180 degrees. And I'm starting with the really obvious, 270 degrees down here. Any problems with that? Okay, so now how many radians is 360 degrees? 2 pi. So it's 0 and 2 pi. You can see that okay? Notice no degrees. We don't put an R. We don't need to. Generally, radians doesn't have units. The textbook, for whatever reason, probably just to help people remember, is putting rad behind everything. That's kind of not normal. So you don't need units. It's almost redundant. So if that's 0 and 2 pi, what is it over here? Pi, yeah. So it's just 1 pi. What would it be over here? Half a pi, yeah. Or pi over 2. A little bit trickier. What's this one?
3 out of 2 pi.
Yep, 3 out of 2 pi. Or 3 pi over 2. Karina and Gavin, please say something if something's not clear or not making sense, or if I'm standing in the way of something too long. Okay, so the reason I'm making you give me these answers is so you can see and kind of figure them out that way, because that's how we're going to do the rest of this. So what is that, brown? Such an ugly color. Now let's just divide these into quarters. These are part of the main angles you need to figure out. So if these are quarters, let's go around. What color is my degrees? Red? So right here, so it's half of this. What's my degrees here? 45 degrees. What is it here?
135.
How did you get 135?
It's like 90 plus 45.
Yes. 135. I know we're not supposed to shut the doors. Are you guys okay if I shut that? I'll open the window. It's nice out. Because noise.
Wait, why aren't we supposed to shut the doors?
Oh, it's beautiful out. What's that?
Why aren't we supposed to shut the doors?
Because the global pandemic. It's like air movement and stuff. This noise is so distracting. There's probably not going to be a sound. There, a little bit of air can get out. Okay. 135 degrees, 180 degrees. What is it here? You can yell out from home too if you want. 225. 270. What's this one? 315. Now you can do 270 plus 45. You can do 360 minus 45. Needs to be 45 away. Okay, so that is the degrees. What color is my radians? Bright green. What is this one? In radians. A quarter pi, yep, or pi over 4. One way to think of that is halfway around is pi. Okay, so it's just in quarters. Pi over 4, this is 2 pi over 4, simplified to pi over 2. What's this one?
3 pi over 4?
3 pi over 4.
Does it matter if the pi's on the top or the bottom?
It does. You can write it as like 3 pi over 4 or 3/4 pi.
Okay.
These are equivalent. It works the same way, but underneath, that's a totally different thing.
Okay, cool.
Okay, good question. Okay, so this is 4 pi over 4. What is this one?
5 pi.
5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2. Anyone? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7. Are you guys okay, Gavin and Karina? Are you still there?
Yeah.
Yep.
And it's all making sense?
Yep.
Okay, cool. Stop me if it doesn't, please. Okay, so now we've got our 45s. Now we are going to do 30, 60, 90. So it's multiples of 30 degrees all the way around. And then we're done. So this one, 30 degrees. This one, you know what? Like, let's be honest. That's pretty well drawn. That's pretty equivalent and all the rest of it. So it's 30, 60, 90. What's this one? What? Sorry? 120. I just saw I didn't put a degrees here. So that right there says 60 radians, which is completely wrong. So let's make sure we include our units. That's why units are always important. What's this one? 150 degrees. So it's 30 from here. It's also 30 from here. Okay? 150 to 180. Next one is 210. Add 30. This one's a little bit in the way. I'm going to move that over. 240. $240, 270, 300, I'm supposed to be doing this in red. Does it matter? You guys okay with that? 300 degrees, 330 degrees. So now we're going to do all those in radians. Okay. Now, if we just look at, because it goes to pi, if half of the circle goes to pi, how many of these 30-degree chunks are there? There's 1, 2, 3, 4, 5, 6. So the 30-degree ones are over 6. And then we'll simplify when we can, but they are over 6. So this is pi over 6.
Wait, how is it 6?
Let me just mark this. Pi over 6. Because for the 30-degree ones, so it goes 1, 2, 3, 4, 5, 6.
Okay.
Okay? So you just remember it that way, that you can break it down that way. Pi over 6, what's this one?
2 pi.
2 pi over 6. Simplified? Pi over 3. Now, if you decide you want to use 2 pi over 6, it totally works. The math works. Everything will add up and work out properly. It's just more to it. And then when you need it in simplified form, which is almost always what your final answer should be, that'll be it. So pi over 3, and then, so this one here, this was 2 pi over 6. This is 3 pi over 6. Okay, 3 over 6 is half. 3 pi over 6, what's this? 2 pi over 3, yeah. 4 pi over 6, which is 2 pi over 3. 2 pi, or sorry, so that's 4 over 6. This one?
Is it 5 pi over 6?
It's 5 pi over 6. Now you also might notice that so these, I'm going by 30s. The 60-degree ones, pi over 3, 2 pi over 3, 3 pi over 3. So there's all kinds of patterns throughout, and it's just counting. I saw this because there's this one goofy account I follow on Instagram, and it's like this blue pill, red pill matrix thing, and it's like, you mean to tell me all math is adding? Yes, it is. It is. All math is adding. It's just tricky adding. 5 pi over 6, 6 pi over 6. What is this one? 7 pi over 6. And this is all on that sheet, by the way. 7 pi over 6. What is this one? 4 pi over 3. Nice, yep. Which is 8 pi over 6.
Yeah.
So that's 8 pi over 6, 4 pi over 3. This is 9 pi over 6, which is 3 pi over 2. But it's just easier for counting. 9 pi over 6. This one is 5 pi over 3, which was 10 pi over 6. One more! Instead of adding and thinking this way, you can always back up. If we up 30 degrees, pi over 6. Down 30 degrees, maybe that doesn't help actually, now that I think of it out loud. 10, 11. 11 pi over 6. You might be wanting to, yeah, it's like, my point was that this is kind of like 12 pi over 6.
Oh, okay.
But yeah, kind of broke down. I had things I didn't share.
Okay, I see.
Yeah.
Now I see.
Yeah. Okay, yeah. So that's pi, it's negative pi, and it is. Remember, this is all positive. This is all standard position. You go backwards, you put in, it's like everything's reversed. Coming down this way, this would be negative 30 degrees, negative pi over 6. Negative 90, negative 3 pi over 2. Yeah. Goes backwards when it's negative. Now, the only thing we have left to do is figure out what the coordinates. Here, we got the coordinates for this one, it's 1 and 0. Coordinates for this one, 0 and 1, negative 1 and 0, 0 and negative 1. Oh, excuse me, we're teaching.
I am related.
Excuse me.
Most of the people.
It's true. Look, now that you're in here, you can take, it's 3 on 3.
So awesome.
Yeah, that's a word for it. So these are the coordinates on any, and like this right here, the 0 and 0 is like just a coordinate plane where this, this is the origin. This is 0 and 0. So right here, at this point right here, this is 1 and 0. And that's this point here. So we're going to figure out what these other coordinates are. Now, it's at this point where you're going to have to do a little bit of memorizing. This, you don't have to so much memorize as know the basics. 360 degrees, 2 pi, then you just break it down. Now, what you have to remember here is root 3 over 2, root 2 over 2, and 1 over 2. They're all the points that haven't been labeled. So like these three, these three, these three, these three are variations of this. Plus and minus and things like that. But this is it. It's root 3 over 2, root 2 over 2. And if it helps you to remember this, root 1 over 2. But the root of 1 is 1. Oh, sorry. You're supposed to say stuff when it's not on the screen, you guys.
It's not on the screen.
Go back to bed. Okay, hang on. Okay? Yeah, that looks okay. If this doesn't record, I quit. I'm not coming back tomorrow. This is what you have to memorize. This is what you have to memorize. And this is in descending order. The root of 3 is bigger than the root of 2. Root of 2 bigger than the root of 1. So this is the longer side. This is the shorter side. Okay? Now I'm going to erase it. Let's use a different color. Let's use orange. So I'm going to start with the easier ones, I think. These are our 45-degree ones. 45 degrees, what's special about a triangle, a 45-degree triangle?
All the same.
Yeah. You're going to have the hypotenuse, and these are all the hypotenuses, by the way, which is also the radius for the triangles we're going to make, which is on the yellow, or not the yellow, it's black and white to you. The various gray shaded triangular sheet. So here, it is root 2. I actually kind of like that color. Root 2 over 2, root 2 over 2. Those are the coordinates to this point. This is the x, this is the y. This is root 2 over 2, this is root 2 over 2. So we'll do them for all of them. So this right here is, but what's different? There's one little difference here.
Yes, negative.
X is negative. So it's negative root 2 over 2, root 2 over 2. What is it down here?
Both negative.
Both negative. Negative root 2 over 2, negative root 2 over 2. Oh, I was like, why is there nothing on my screen? There's nothing here. And I'm like, what? Oh, because there's nothing there, because I erased it. So to make sure everything is showing up. Last one.
Y is negative.
The y is negative. So it's root 2 over 2.
You're right though. I'm afraid
Yeah. And so, negative! So those are our 45-degree ones. They're the same. Those are the easiest ones. So now I'm going to make you think. It's not that hard. This 30-degree angle, and I'm not going to draw in all the triangles. It gets very, very busy. It's already busy. I'm already worried about where I'm going to fit the other points. But in this triangle right here, you've got the y here and the x here. Which is longer, the x or the y? So the x is going to have root 3 over 2, the y a half. And it's like, once you have these two, you can do all the rest of them. Watch. What are the coordinates for this point? Like this is this point on the circle. Okay, that's that point on the circle. Say this point on the circle those are the coordinates. Those are the x and y coordinates of that point. Pythagorean theorem, we want to figure out how long this hypotenuse is. A squared plus b squared equals c squared. This squared is 2 over 4. This squared is 2 over 4. Half and a half is 1. The root of 1 is 1. It's a unit circle. It all connects. It all makes sense. So what are the coordinates for this bad boy here? The x value is 1 over 2. The y value is root 3 over 2. Anybody not understand that? Anyone?
It's good.
Okay. Gavin fell asleep. Are you okay?
Yeah.
Maya? This is
I'm
all.
trying to figure out where I'm supposed to put this because I have all these numbers.
You can, if you want, like, because you have one of the sheets that are double-sided. You can use one that's all degrees, do another one that's all radians, do another that's all the coordinates, however you want. However you want. Previous years I've done a quiz where you just have to fill this out. Did I do that last year?
I think so.
Oh, maybe last year I just did the first quadrant or something.
Yeah.
Okay.
I feel
We
like
did
this
this
one
one
at
over,
home
like, when we were
last
at
year. It was
home.
the first
We did
year that we
this.
Oh yeah, that's
So-
right. I hate that stuff. So I think we might do that again with this, but it'll be everything. It'll be all of this. Okay, so let's just keep going. What are the coordinates for this one?
Negative 1 over 2 and root 3 over 2.
Negative a half, root 3 over 2. I'm running out of room too. This one,
Negative root 3 over 2 and 1/2.
Jamie, this one.
That one, just because it's negative, so would it be like the smaller one or the bigger one? Because I'm thinking it would be the smaller.
Okay, think of it this way. This is the triangle. Which side is longer, the x or the y?
Oh, the x.
Okay, and what is it?
So the x would be the negative root 3 over 2, and then negative a half, or y.
Maya,
Yeah.
you want to take a stab at this one?
Oh,
240 degrees.
I'm not supposed to do that.
Long y, short x.
Oh, it would be negative a half and negative square root of 3 over 2. I was just writing how to do that.
Yeah, I know. Yep, I know. I just wanted to give everybody a shot. Sam, have you done one?
Yes.
Gavin or Karina? Who's doing 300 degrees?
Negative half. Nope. Just a half, and it's positive, and then negative root 3 over 2.
Why is the x positive
Because it's on the right half of the thing.
of the origin? Yep, and the y is
Yep.
below. Yes, you got it. Gavin, are you still there? Do you want to do the last one?
I can't see your screen right now.
Oh crap! You can't see anything?
No, there we go.
Oh.
It's root 2 over 2, negative root 2 over 2, and 1 over 2.
You're mostly right with the half. It's negative a half because it's y, so it's down. Does that make sense?
Yeah.
Now it's positive x and it's the biggest x. The root 2 over
3
2,
over 2.
those are only the 45 degree angle ones. The root 2 over 2 always go together. So what's this one?
Root 3 over 2.
That's right. Root 3 over 2, and it's positive because it's on the right side. That's the unit circle. Isn't that pretty? Look at that. It's actually so messy looking.
At least they're different colors.
Yeah, well, I tried. Mostly different colors. The degrees are supposed to be red, but they went brown. Should we have an assignment? What do we do? I'm just trying to think. Like, what is, in all honesty, what is just the best pedagogically to do from here? Because the assignment, I'll share it with you guys at home. Share screen with this.
It's basically the same thing without the circle involved.
Yeah, so basically, I'll tell you guys.
Oh, what?
I don't even know what that is.
Oh, and by the way, I didn't even start this class with questions from the weekend or the assignment. Are there any?
Oh,
I
yeah.
didn't get that far, so.
Okay.
After I talked to you, I just didn't even look at it all. I had to go to dance. So
Okay, so this is what
6 hours.
we're going to do. I'll get you guys to write this down, or I'll put this on Google Classroom. Yeah, the video will be on Google Classroom, so you can see this. It's reading through page 169 to 173. There's a different way of explaining this. It's not bad. It might help if you're thinking, man, I understood it the other way. I don't even want to look at this. Then don't look at it. There is an assignment, page 173, 1 to 4, but I'll give you 2 days for it. Okay, so what is tomorrow? Wednesday?
Yeah.
So Wednesday is just time for this. And also because I realized the previous lesson was kind of heavy. And we didn't even go over questions, which is I think what we'll do now, if we have them. Did you two at home, did you have questions from the last assignment?
No.
No?
No.
Okay, so you guys are good. So I'm probably going to stop the recording then. But do know that we won't be doing anything new tomorrow. It'll just be this assignment and figuring out the rest of the other one. Yeah, any questions? Am I forgetting anything before I sign off with you guys?
You're old.
I'm old?
I said you're old. G.
Oh. I just hear, you're old. Okay, all right. So, yeah, if you think of something, I feel so frazzled. If you think of something, then, yeah, just email or Google Classroom or something. All right? Okay.
All right.
I'm gonna sign out with you guys. Have a lovely day. I hope everybody in your family's healthy there, Gavin.
Thank you.
We'll talk to you guys later.
Bye.
Bye. What a weird. Oh yeah, it didn't stop recording.